I'm R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this video, we are going to see the topic Reflector Antennas for the course Transmission Lines and Antennas. So, a reflector antenna is a device that reflects electromagnetic waves. The antenna reflectors can exist as a standalone device for redirecting the radio frequency energy, or it can be integrated as a part of an antenna assembly. The function of a standalone reflector is to direct the electromagnetic energy generally into the radio wavelength range of electromagnetic spectrum. Reflector antennas are widely used to modify the radiation pattern of the radiating element, that is an antenna, and with increasing gain in a given direction. So there are a variety of reflectors are available. So the flat reflectors, there are different types: large flat reflector, small flat sheet reflectors, and thin reflectors where the dipoles are very thin. The reflector backside reflector element also a thin antenna, and the corner reflectors, we have active corner reflector where it has the radiation source at the center, and a passive corner reflector, they will not have source, but they will send the incoming electromagnetic wave in a particular direction. And the parabolic reflector, a well-known antenna, and in a parabolic reflector we have the elliptical reflector, hyperbolic reflector, and the circular reflector. So these are many varieties of reflector antennas. So a corner reflector, as we said already, it reflects the incoming signal back to the direction from when it came, commonly used in radar. A corner reflector antenna is a type of directional antenna used at very high frequency and ultra high frequencies. It consists of a dipole driven element mounted in the front of the two flat rectangular reflecting screens joined at an angle, usually 90 degree. Flat reflector, which reflects the signal such as a mirror and is often used as a passive repeater. Flat reflector such as used in sector antenna, a corner reflector used in ultra high frequency television antennas. Common integrated reflector types are parabolic reflector, which focuses a beam signal into one point or directs the radiating signal into beam. Parabolic reflectors are microwave antennas. The most well-known reflector antenna is the parabolic reflector antenna, commonly known as satellite dish antenna. So these antennas are widely used for radio and wireless applications. Parabolic reflectors typically have a very gain 30 to 40 decibels, and they have a reasonable bandwidth, can be wideband in case of huge dishes. The smaller dish antenna typically operate between 2 to 28 gigahertz. The large dishes can operate in the very high frequency region 30 to 300 megahertz, but typically need to be extremely large at this opening band. So this is a picture of an example of a parabolic reflector antenna, and reflecting parabola is at the back side. At the vertex, at the focal point, we have a feed antenna. So for feed purpose we can use many type of antennas, and this is the geometry of a parabolic reflector. A parabola which is P dash to P1 dash to P2 dash, and at line tangent, and it is kept in x and y direction. At focal point is denoted as F. We have a where we kept a feed element. So the point F is the focus, V is vertex, the line joining F and V is the axis of symmetry, PQ are the reflected rays, where L represents the line directrix on which the reflected points lie, and hence as per the above definition, the distance between F and L lie constant with respect to the waves being focused. The reflected wave forms a collimated wavefront out of the parabolic shape. The ratio of focal length to aperture size F to D is known as F over D ratio, and it is an important parameter of a parabolic reflector. Its value varies from 0.25 to 0.5. The law of reflection states that the angle of incidence and the angle of reflection are equal. This law, when used along with the parabola, helps the beam focus. The shape of the parabola, when used for the purpose of reflection waves, exhibits some properties of the parabola which are helpful for building an antenna using the waves reflected. All the waves originating from focus reflects back to the parabolic axis. Hence, all the waves reaching the aperture are in phase, and the spherical wave is converted into parallel wave by the dish. As the waves are in phase, the beam of radiation along the parabolic axis will be strong and concentrated. Following these points, the parabolic reflectors help in producing high directivity with narrower beam width. And the parabolic reflector antenna, its construction, and it is used for transmitting signal. The signal from the feed comes out of a dipole or horn antenna to focus the wave onto the parabola. It means that the waves come out of the focal point and strike the paraboloidal reflector. So this wave now gets reflected as collimated wavefront as discussed previously to get transmitted. So now the parabolic reflector is otherwise called as microwave dish. We know the parabola is a two-dimensional plane curve. A parabolic reflector or paraboloid is a three-dimensional curved surface. It produces a parallel beam of circular cross-section because the aperture of the paraboloidal is circular. The radiation pattern has a very sharp major lobe and minor lobes which are very smaller in space, and the radiation pattern is given at the right side. So now a very important term is called as spillover and back lobe in parabolic reflector antenna. So here the spillover is some desired rays are not captured by the reflector, and this constitutes spillover. In receivers, spillover increases noise pickup, which is troublesome in satellite ground stations. Some radiation from the primary reflector occur in forward direction. This is known as back lobe radiation, not desirable as it can interfere destructively. And there are various feed systems of reflector antenna: dipole feed, horn feed, end-fire feed antenna, Cassegrain feed in the diagram. Advantages: reduction of minor lobes, wastage of power is reduced, equivalent focal length is achieved, feed can be placed in any location according to our convenience, adjustment of beam is done by adjusting the reflected surfaces. Disadvantages: some of the power that gets reflected from the paraboloidal reflector is obstructed, so this becomes a problem with smaller dimension paraboloid. So assessment: which of the following wave conversion mechanism is performed in a parabolic reflector antenna? The answer is B, that is spherical to plane. And which of the following is a dual reflector antenna? The answer is Cassegrain antenna. Thank you.